The desert locust is a well-known plague affecting large area from North Africa to India that compromise the food security and the economy of fragile countries. The main goal of this project is to develop a geospatial risk outbreak model for the timely location of desert locust invasion and mapping desert locust risk zones in Eastern Africa region. In this work, we present a case study where Earth observation data and climate data have been processed and analyzed with artificial intelligence techniques with a twofold scope of assessing the impact of locust presence and to predict the locust swarm migration by locating the suitable breeding areas. In this case study, Earth observation change detection techniques have been applied to Sentinel-1 and Sentinel-2 for measuring the impact of locust presence in terms of crop and vegetation damages and observation of migration process. The climate data have been analyzed in order to create a prediction climate model of locust habitat and related environment conditions for locust development. Climate parameters have been compared to locust presence occurrences with machine learning techniques to identify climate temporal dependencies and correlation for locust risk prediction. The locust impact assessment is based on Earth observation change detection analysis. To start with this process, the satellite products like Sentinel-1 and Sentinel-2 were acquired from Copernicus Open Access Hub. The pre-processing phase consists on the vegetation index extraction. The NDVI, the normalized difference vegetation index, can be computed with optical satellite imagery and provide useful and accurate information on vegetation status. Sentinel-1 data doesn't have vegetation index as NDVI to analyze the evolution of vegetation. To this scope, a machine learning method have been applied to compute vegetation index on Sentinel-1 data and analyze in time the evolution of vegetation over the area impacted by the locust. The last step of the process is the change detection analysis applied to the vegetation indexes to identify those areas affected by locust presence. The second part of this work deals with the analysis of climate parameters, time series that are supposed to be correlated with the locust presence. This analysis is based on machine learning techniques, and the scope is to create an environmental model with the capability to predict the locations with good climate conditions for locust presence and development. As for the previous analysis, also in this case the process starts with the data collection. 8 climate parameters from Copernicus Era 5 data collection concerning temperature, soil moisture, wind and rain have been selected to be correlated to the locust presence occurrences. The climate data have been analyzed against the locust presence data collected from the FAO Locust Hub. The first phase of this analysis is represented by the dataset characterizations that includes the identification of trends, geospatial cluster and seasonality. The second phase deals with the machine learning approach, where different neural networks have been selected and tested to identify the best solution and the best configuration for the prediction model. The results achieved in this study can be considered quite good for what concerns the locust impact assessment, since the Earth observation data change detection method is consolidated and the Earth observation data Sentinel-1 and Sentinel-2 are able to provide detailed information about vegetation status and crop damages. For what concerns the locust presence prediction, the best neural network identified is the feed-forward neural network with the Adam optimization method. Unfortunately, the accuracy of this method is seriously compromised by the trained dataset of locust presence occurrences that is strongly unbalanced, with more records of confirmed presence with respect to confirmed absence. With a more complete and representative dataset of locust occurrences, the machine learning models can be improved to reach a better accuracy for prediction purposes.